Hello, ladies and gentlemen. This is Mr. Santoro with the next installment of Math 12R screencast lessons. So tonight's, well, I'm recording it at night. I'm not sure when you guys are going to watch it, but I'm recording it in the evening. Um, this lesson is regarding the motion of a free-flowing object. So we've spent a couple of days looking at particle motion problems. So this is these are problems, motion of an object in 2 dimensions. For instance, the ball being dropped from a height or thrown up in the air can be modeled by an equation that gives the position of the object as a function of time, which is pretty much what we've been looking at, S of t. So there's a general equation that describes this kind of motion. It's S of t equals 1/2 a t squared plus v sub 0, which is your initial velocity, plus s sub 0, which is your initial height. Velocity as a function of time is at plus initial velocity, and acceleration with regard to time is just equal to a. So there's a couple of things you have to keep in mind. If the height is in feet and time is in seconds, then a is equal to negative 32 feet per second squared. If the height is given in meters and time is in seconds, then a is equal to negative 9.8 meters per second squared. Now this is something that I know that they look at on a regular basis when they're doing these type of problems in physics. So the physics students tell me that I've rounded the 9.8 meters per second squared and maybe even the 32 feet per second squared. But for our purposes, I don't need to carry it to any more decimal places than that. Okay. So suppose the ball is dropped from a window 20 feet above the ground. You have to build the equations in this step, the S of t and the V of t, etc. Okay. In these problems, you have to build your own equation. So let's take a look at this. The ball is dropped from a window 20 feet above the ground. So that's your initial height, your S sub 0, which is the last term in the equation. Okay. So if we build this equation, S sub 0 is 20. And since it's feet, we're going with the negative 32 feet per second. So you just put that into the equation. S of t equals 1/2 times negative 32 t squared plus 0t, because the initial velocity was 0, plus 20, which is your initial height. And on the right side, I'm looking at building the v of t function, which is just negative 32t, because your initial velocity, v sub 0, your initial velocity is 0. So if we continue on the left side, S of t is equal to negative 16t squared plus 20. Your a of t on the right side, which is this up here, is just negative 32. So there are your functions. You have S of t, v of t, and a of t. The problems we were looking at the last couple of days, I gave you the S of t. Now you've got to take the components from the problem and build that function. And then v of t is your first derivative, and a of t is the second derivative. So now that we've built the function, let's now answer some questions. Find the height of the ball after 1 second. Well, height is location, so we're going back to our original function, the S of t, and we'll evaluate for S of 1. So negative 16, which is 1/2 times negative 32. Okay, that's where that came from, by the way. Times 1 plus 20, so negative 16 plus 20. So after 1 second, the ball is 4 feet high. Now let's find the velocity of the ball after 1 second. The velocity, here's your v of t function up here. So we'll evaluate v of 1. So the velocity is negative 32 feet per second. The next one is a 2-part question. First part is, when will the ball hit the ground? And what will its speed be at that moment that it hits the ground? So when will the ball hit the ground? That means the S of t is 0, because its height is 0. So you take the S of t function and you set it equal to 0. And you get 0 equals negative 16t squared plus 20. You add 16t squared to both sides. And you have 16t squared equals 20. You divide both sides by 16. So t squared is 16 over 20 or 5 over 4. Then you take the square root of both sides. T is equal to the square root of 5 over 4, or the square root of 5 over the square root of 4, or the square root of 5 over 2 seconds. So the ball will hit the ground in radical 5 over 2 seconds. Its speed at that moment, we now go to the v of t function, and since we know time is radical 5 over 2, you evaluate that function for radical 5 over 2. So on the right side, I put the radical 5 over 2 where the t appears. When you multiply by negative 32, you get negative 32 radical 5 over 2, which is negative 16 radical 5 feet per second. Now, in some problems, even though negative 16 radical 5 is an exact value, you may be asked to put that into a rounded form. So if we were to round it to nearest tenth of nearest tenth, it would be negative 35.8 feet per second. That's the velocity or the speed the moment the ball hits the ground. So there were a lot of things going on in the screencast. So if we recap a little bit, the motion of an object in 2 dimensions being dropped from a height or thrown up in the air. So you've got the S of t function, the v of t, and the a of t. Now, in the S of t function here, t is time, a is acceleration, v sub 0 is your initial velocity. In many cases, that will be 0, but you have to read the problem. And the initial height is s sub 0, that's the last term. So if we look at the example I gave you, the initial height is 20 feet, which is here. And if it's dropped, that means its initial velocity was 0 because somebody was holding the ball. Okay. So we talked about some of these things in class the last couple of days. What's the initial velocity if I have something and I drop it? So just keep in mind all the things that we've been speaking about in class. And go back and replay the screencast if you need to. We'll be doing practice problems in class. And there will be a quiz on the screencast. So thank you for tuning in to Math 12R screencast lessons.